prove that one side equals the other side. So we'll start with our tangent theta over sine theta side. And this is one of those where you have to change things into sine and cosine. So I'm going to change tangent into sine over cosine. And then I still have sine, but since I have a fraction on top, I'll make this a fraction also. And remember, a division is really, or sorry, a fraction is really division. So this is going to be sine theta over cosine theta times the reciprocal. When you divide by a fraction, you multiply by the reciprocal. And then as you look at this, we have a sine on top, a sine on bottom. So you get 1 over cosine. And 1 over cosine, according to the identities, is secant. Okay, so this will be another proving one. So I'm going to start with the left-hand side. I've got tangent of x plus cotangent of x. And I'm going to rewrite that into sine and cosine, I think. There's probably another way to do this, but this is just what I'm thinking of right now. So I've got sine x over cosine x plus cosine x over sine of x. And whenever you have a fraction, you need a common denominator. So this one needs a sine. And this one needs a cosine. So now I have sine squared x plus cosine squared x all over cosine x times sine x. Now I hope you guys all see our identity here. Sine squared plus cosine squared is 1. Bless you. And then if we look at what we're trying to get secant and cosecant. Well, secant is 1 over cosine and cosecant is 1 over sine. So that's what we got. So on this problem, I first want to get my sines together. So I'm going to add sine x over. So I want to get sine by itself. So we have sine. Are you sure there's not? Oh, that makes more sense. Sorry. Okay, so we have 2 sine x equals the square root of 3. And then I'm trying to get sine by itself, so I need to get rid of the 2. So now I have that the sine of x equals root 3 over 2. So we're going to the unit circle and we're saying, when does sine equal root 3 over 2? Sine is the y value. It needs to be tall because root 3 over 2 is the bigger one. So I'm looking here and here, right? So I'm looking at pi, or x being pi over 3 and 2 pi over 3. Okay, so we are trying to solve for x, I believe, right? Or are we trying to show that one side?
Find all general solutions.
Okay, so we're solving for x. So what I see when I look at this is I see that I have a sum formula here and a subtraction or difference formula here. The one thing that I noticed on your guys' test, the big mistake that was made was this minus right here. Okay? This minus is going to affect you big time, and a lot of you are messing up with that. So be very careful with that. So here we go. Let's do the sum formula for the cosine of x plus pi over 4. So the sum formula says I'm going to go the cosine of the first one times the cosine of the second one minus the sine of the first one times the sine of the second one. Okay, now when I do the formula here, this minus sign is going to have to be to everything. So I'm going to put a big parenthesis there. And then I'll distribute that minus sign later. So now it's going to be the cosine of the first thing, cosine of the second thing, plus the sine of the first thing, sine of the second thing, equals 1. So then I need to distribute that minus sign to both of them. I'm also going to simplify this a little bit for myself. Cosine of pi over 4 is root 2 over 2. Sine of pi over 4 is root 2 over 2. I'm putting the number in front if that's okay with you guys. And then this minus sign goes here, so I have minus, and then the cosine of pi over 4 is root 2 over 2. And again, the minus goes here, so it'll be a minus. And then sine of pi over 4 is root 2 over 2. And then sine of x equals 1. Now, you have to be careful with your canceling. Because of that negative sign, some things cancel, some things don't. As I look at this, this is positive and this is negative. So those are going to cancel out completely. This one's negative and this one's also negative. So that means I need to put them together. And I have 2 of them then. So it'll be minus 2 of the root 2 over 2 sine of x equals 1. And so then my 2's cancel. So now I have negative root 2 sine of x equals 1. I'm going to divide both sides by negative root 2. And then I'm going to rationalize it, so I get negative root 2 over 2. At which time then we look at the unit circle. Sine is the y value and it's negative, so I'm looking at the third and fourth quadrants. And we're looking at multiples of pi over 4, so it'll be 5 pi over 4 and 7 pi over 4. A lot of you took that 22.5 and you put it in for u. The thing is, if I put 22.5 here and I divide it by 2, that doesn't give me 22.5, right? So our first job is to figure out what number goes here so that when you divide it by 2, you get 22.5. So you're going to do the opposite. You're going to multiply by 2, you get 45. So now I'm finding the tangent of 45 over 2. Because if I do this, I get back to this. These two things need to be equal, right? So if I take 45 divided by 2, I get 22.5. That means u then is going to be 45. So now as I set this up, I get 1 minus the cosine of 45 degrees over the sine of 45 degrees. So a lot of you that didn't get to that 45 already were having troubles because it was 22.5, and it's like, how do you do that? It's not in the unit circle. Okay, now the rest of this was just kind of some crazy algebra, hoping that you guys knew your crazy algebra skills. So what happens here is we get 1 minus root 2 over 2 all over root 2 over 2. Then we have to get a common denominator. So that'll be 2 over 2. So now I have 2 minus root 2 over 2 over root 2 over 2.
Is there a thing that switches those? I mean, like the tangent 1 minus cosine over sine?
There's another one. There's two formulas here for this.
Is it sine over 1 plus cosine?
Uh-huh. Yep. Okay, then my 2's cancel out here, right? So then I have 2 minus root 2 over root 2. And then you have to rationalize that. I was really nice in the grading on this, by the way. Then I get 2 root 2 minus 2 over 2. And then the 2's here, I can cancel all these 2's out. So then I get root 2 minus, and since that canceled out, I get a 1. Right? Since this canceled out, I get a 1. And that should have been your answer. That doesn't mean I marked it wrong if you didn't get there. I was really happy, even if you got here at this point, just because people really messed up with the 45, right? If you did the other formula with the 1 plus cosine on the bottom, you would have had to multiply by the conjugate to get rid of the square root.
Oh, I did stuff.
Yeah. I'm not as worried about that as I am just in the fact that you could figure out the 45 part at the very beginning. Okay.
Well, I think we don't now.
So we have to start by replacing cosine of 2x with the double angle formula. Now you guys, there are 3 formulas. So there's our 3 formulas. Now if you look, one of our formulas has cosine and sine in it. One of our formulas has just cosine and one of them has just sine. Now as I look at what I had up here, I noticed that besides what I have here, I also have a cosine. So I'm thinking it might be smartest to just use the one with cosine in it, right? Don't use the one with sine in it. Don't use the one with cosine and sine in it. Use the one with cosine, because I'm thinking they're all squared here. So I'm thinking we're going to have to double bubble or something along those lines in order to do this problem, which means we need to have the same function. So I'm going to pick the second one. Okay, I'm going to pick that one, and we replace cosine of 2x with it. So now I have 2 cosine squared x minus 1. And then I still have a minus cosine x. I'm going to rearrange it just so they're in descending order like we usually work with. And now I'll box them out. So 2 cosine squared, a minus 1, so we'll need a 2 cosine and a cosine, a 1 and a 1. So it'll be 2 cosine x and cosine x. And then I will need this one to be negative, because I need a negative cosine. So it'll be 2 cosine x plus 1 and 2 cosine, or cosine x minus 1. And those all equal 0. And so now I set each one equal to 0. and solve. So I get cosine of x equals negative 1/2 and cosine of x equals 1. So on the unit circle, cosine is the x value. It's going to be short because it's a 1/2 and it'll be negative. So there and there. So that means x is going to be 2 pi over 3 and 4 pi over 3. And then the x value is 1. That brings me right here. So we've got 0. So here we're supposed to simplify this down to one trig function. So I'm going to get a common denominator. That's automatically what you should go to when you have fractions like this. Alright, so on this first one it needs a 1 plus sine u. That was backwards. It's a sun now. You all know what I'm talking about. And this one needs a cosine. So as I go to multiply these two together, that's going to be a FOIL or use the box to do that. So you're, what? So you're going to get 1 plus 2 sine u plus sine squared u. Is that okay, or do you want to see the box? We're good. Okay. And then on the next fraction, we multiply those together and we get plus cosine squared u. All over 1 plus sine u times cosine u. Okay. All right, then I'm noticing a trig identity here, right? That's 1. So we will have one. We'll have 1 plus 1, which gives me 2. And then I still have the 2 sine u. Now if I remember this right, a lot of you kind of got stuck here. Like, what do I do with this? Well, I know it might be more obvious than it should be. I don't know. Do you all notice there's a 2 in both of these? Does everybody see that?
Yeah.
There's a 2 in both of them. So I'm going to take out a 2 from both of them. So I take out a 2, and then you have to do that correctly. When you take out a 2, you're dividing by 2. So then I look here and I go 2 divided by 2 is 1. And then I go here and I say, oh, I divide by 2, that cancels out, and I just am left with sine of u. And I still have the bottom. And then I have 1 plus sine u, 1 plus sine u. Those cancel out. So we have 2 over cosine u. And typically you don't leave it as a fraction if you don't have to. So that cosine u, I can rewrite that as 2 times secant. And that would be our one trig function.